Our goal in this video is to show how to find the power series representation for sin of x. We are going to be using Taylor series, which have the formula given here. We will work at x equals 0, so we have the sum from k equals 0 to infinity of the kth derivative of f of x evaluated at 0, divided by k factorial times x to the k. This is a special case, called a Maclaurin series. When we do this work for sin of x, we need to find a pattern in the derivatives of f of x. The original function is sin of x, the first derivative is cosine of x, the second derivative is negative sin of x, the third derivative is negative cosine of x, and the fourth derivative is sin of x. From here, the pattern repeats. To get the coefficients for the Maclaurin series, we start plugging in 0 to the derivatives that we found. Notice that the function value and the second derivative are both equal to 0, f prime of 0 is equal to 1, and f triple prime of 0 is equal to negative 1. The pattern that emerges is that all even coefficients will be 0, while the odd terms will alternate between positive 1 and negative 1. So we can start writing out the terms. Figuring out how to express this in terms of k is a bit tricky. We end up only needing to look at the powers of x raised to the 2k plus 1, with 2k plus 1 factorial being in the denominator, because 2k plus 1 is always an odd number. We don't need to write the even numbers, corresponding to 2 times k, since all of these are equal. We end up with negative 1 raised to the k in the numerator, because this makes the term in the numerator alternate between 1 and negative 1. So this is the formula for the power series of sin of x. It's worth memorizing, and to memorize it, it's helpful to know where the formula comes from.